So let's talk about the technical perspective of it. And this is something that you may not have heard about it, but from a technical point of view, of course, there is no more need for creating containers. No containers to manage, no servers to virtualize, which I touched on earlier. There is no infrastructure to manage. Just those three alone here, number 1, 2, and 3. This, from a operations perspective, from a staff, just from a cost perspective alone, and the points of failures that can happen within the first 3 points here are tremendous. Those are very large points, and I think any organization should seriously consider diving in and using cloud provider as the DevOps department. Number 4, with fine-grained deployments, you have that capability with serverless computing. When I deploy a single function, a Lambda function in AWS's case, when I can deploy a function that's completely isolated, I have fine-grained deployments. So in a serverless environment, and I'll show you this a little bit later from now, what this would look like, from an implementation perspective. The best platform in the world. What I mean by that is that the serverless environment that's being provided to you from a cloud provider is really, you can consider that as the best platform. It's the best compared to any in-house operations that you might have. Even if you have a very large IT department, it's very unlikely you can compete against Amazon's AWS implementation, and for them to maintain it 24/7, to provide physical access security, logical access security, infrastructure, uptime, and so on. So you can consider that as a best platform practice. Physical security, like I said, and virtual security, and the massive scalability. So that brings up another point. When, say, you are virtualizing an existing system, you take the server images, you put it up in the cloud, and you have one or multiple copies running in the cluster for a particular domain. That's fine. But hopefully your business will grow. Eventually, the whole reason why you're in business is because you want to generate revenue. In order to drive revenue, you need to increase your sales or some sort of way to increase your revenue. And usually that means the demand will increase. And by increased demand, you need to be able to keep up with that demand. And how do you do that? Traditionally, you threw in more hardware. You're literally vertically scaling with massive more hardware, which is from the 90s. This is something that nobody wants to do that anymore today. You don't want to scale by increasing vertically, meaning you're adding more powerful machines, more powerful hardware. That doesn't make any sense anymore, not today, with cloud computing available. If you're doing that, you're not taking advantage of cloud computing. So I'm telling you, for massive scalability, if you design a cloud solution, even with a greenfield project, and the capability of massive scale should be taken advantage of. This is one of your top priorities in a cloud computing environment. That's why you're using, one of the reasons why you're using cloud, right? And so with serverless computing, since I don't have to manage servers, I don't have to provision them, I don't have to predict what the load will be, right? If I have certain spikes in the time of the day or time of the week, or certain events throughout the year, with serverless computing, that capability is always there from day one. Even if you have massive scale in hikes, there are some things we need to tweak just to add the initial configuration. I mean, in this case, AWS in the account. But in general, the massive scalability is available from day one. You don't have to worry about using 10 million people, 10 million or 100 million users using your system, or just 1,000. And so from a technical perspective, this is really nirvana. It's fantastic. It's absolute cream of the top. And then last point, incredible reliability. Because I don't need to maintain infrastructure, I don't need to maintain the hardware and the server systems, the clusters, and so on. I have increased reliability for free out of the box because I'm using serverless computing. I don't have to do anything extra. I have built-in reliability. That is worth a whole lot of money. But really, you're getting it literally for pennies with serverless computing. And so reliability, as you remember earlier what I showed, can affect your customer experience incredibly. So you're getting increased reliability just by using serverless computing. That to me is worth it alone, considering serverless computing. Oh yeah, let's look at a basic scenario. Here in this case, you create a serverless function locally, an engineer would, or a developer. The serverless function would be then uploaded to AWS Lambda. Lambda is the environment that executes serverless function in Amazon AWS. That Amazon Lambda takes care of the scalability and the reliability that I touched on earlier. And then you want to expose that particular function through some sort of external service. In this case, it's AWS API Gateway. API Gateway is, you can think of it as Tomcat or IIS as a web server, but much more powerful and with a whole lot of features coming free out of the box. And so it actually replaces your typical Tomcat or Apache or IIS web servers that you used to. And so this is completely replaced with the API Gateway service, of course. And there's so many other cool features in it, which I can't go in detail yet, but things like throttling, security, model checking, and so on. There's a whole bunch of features in there alone. And so eventually your customer uses some kind of system, a UI front-end, desktop, native application, maybe a browser, maybe a mobile app, and accessing your solution through this API gateway, and then access the Lambda. This is a very basic scenario, very, very small. You could build it like this. Next, if you remember earlier when we talked about hexagonal architecture with the core domain in the center and then application services, domain services and application services around it, then the adapters and then the ports. And so the concepts of CQRS and event sourcing, it's really too deep to explain this here. I have the other courses where I go into much more detail, but what I'll show you here is just a technical perspective on a scenario where you could use CQRS and event sourced environment a little bit more elaborately with the cloud services. So here we'll start out with the user using a mobile device or desktop app, like I said, not just browser based, but desktop applications, which are still the king in the world. User signs up, creates an account with another AWS service called AWS Cognito. Cognito is really the user management and authorization and authentication service that you want to utilize, especially the more users you have to deal with. So first step, user signs up, and then authentication is handled by the Cognito service. Next step, after the user has been validated, email is validated, and or the phone number has been validated. At this point, the user can sign into your application through AWS Cognito. There are things like single sign-on support. Cognito itself is it would take me another course just to explain Cognito on the powerful features that it has. After the user signs in successfully, the AWS Cognito will use the authenticated user and allow the user, or the application in this case, to make a call to the API gateway. And that API gateway has an endpoint exposed to let the user use that endpoint. Next, the AWS gateway can be configured to call then your first Lambda function in your serverless environment. In this case, it triggers your Lambda function, and your Lambda function in this example would take that command that came in from API gateway and or the request rather, then creates a command. That command then gets passed into a queue, into AWS queue, SQS. So Lambda will take care of the push and the pulling when the queue actually gets populated with items on it. So the Lambda service will take care of that for you, and so it's very nicely done actually. So the way AWS implemented it, so Lambda pushes the command to SQS, and then the Lambda service then will take the command that ended up in the queue, because your core domain model subscribes to a domain event, in this case to a command that came in. So when the command comes into a queue, it then triggers a Lambda that executes the domain model. Remember at the beginning I was talking about application services, and in the application services one of them was command handlers. And so these command handlers can process incoming commands in an event source system, and that command now comes into the application service. And so here it triggers the domain model. The command handler converts it into a proper call to an aggregate inside the domain model, and the aggregate itself will handle the command, process it, so to speak, and applies on the rules that needs to be processed. And eventually, when the domain model at the core is done with this process, it will trigger a domain event, like I touched on earlier. And so when the domain event gets triggered, first thing is it will be stored in this DynamoDB event store. In DynamoDB, DynamoDB is another AWS service. It's a database service. It's a NoSQL storage. It's a key value storage, really. And so the domain event gets stored in DynamoDB. And then asynchronously, out of this DynamoDB comes the domain event that's getting broadcasted to anybody who's interested in this. And so in this case, in step number 8 here, the domain event gets broadcasted, and the read model, in this case a MySQL cluster, it's an AWS service, relational database management service. The domain event gets passed along to the read model, so that the read model has a chance to consume that domain event, and then take that domain event and then form it in such a way and process it so that it can be used later on, maybe for reporting, maybe for the application down here that we had at the beginning, for the mobile app here or any other application that has a certain view on the screen that needs to be seen, already prefetched and pre-calculated. This processing can all be done in the read model itself, so that the application, there's more pieces to it, but this gives you a rough idea of how the application can process commands, the user interaction, and how the services can work in tandem together to generate a CQRS and an event source system. CQRS stands for Command Query and Responsibility System, I believe, if I remember correctly. So this is a small example, also from a technical perspective. So serverless computing, just to sum up a little bit, is great for event-based solutions. It's great for event source systems, and Lambdas fit perfectly for event processing, because Lambdas are stateless. Lambdas are the serverless functions, and generally they're stateless. And those three combined for serverless computing make a great case for really take advantage of this evolution that we had seen now in the last 13 years, especially with AWS that I have seen, and delivering great software. So I hope this was useful to you. Please contact me if you have any further questions, if I need to correct anything, if you think that I misspoken anything, but I believe very strongly on the points that I've shown you, and because I've done it, I have implemented them. It's working fantastic. It's just a nirvana of serverless computing capabilities today. Why don't you take advantage of them? That's the question you should ask. Right, I'll see you in the next lecture.